Hey guys, Miss Subin here. I just wanted to go ahead and go over some things that you should already know from 7th grade or you may have forgotten from 7th grade. So today I want to talk about adding integers using integer chips. Now, there are a couple different ways that you can think about integers, but integer chips are a good way to problem solve here. Integer chips are just little pieces of plastic that look like coins that are either red or yellow that represent positive or negative values. Here what I'm going to do, I'm going to be drawing the integer chips just like you would do at home. So let's look at a couple problems and see if we can figure. All right, here's our first problem, 1 plus 2. Some of you probably already figured out the answer, but let's show an answer we know with our integer chips, a process that we're going to use for harder problems. First thing, I like to have addition in the middle. All of our problems today will have addition, but we'll see that as something that will become problematic with subtraction. But we have an addition sign in the middle, so that means that we're ready to draw. So I have positive 1. We know it's positive when there's no sign in the front. Positive 1 we can represent by using one positive integer chip. We're going to combine that with positive 2, which we can represent as 2 positive integer chips. This type of problem isn't too bad because we have a positive number being combined with a positive number. When they're both positive, that means they agree with each other, and it ends up working out in our favor. We don't have to do anything except for count up the chips. I have 1, 2, 3 positive chips. My answer is going to be, I clicked the wrong button. Positive 1, 2, 3, positive 3. There's my answer. Not too bad when the signs agree with each other, because 1 plus 2 you already knew was 3, but this is how we can show it. All right, let's try another one. This time we have a negative 3 plus a negative 2. Again, I like having that positive in the middle, with a plus sign in the middle, so I know that I'm combining them together. So let's go ahead and represent each part of our problem using integer chips. I have negative 3, which can be represented with negative 1, 2, 3 integer chips. And then I have negative 2, which can be represented with 1, 2 negative integer chips. Again, this problem doesn't look too bad because we have negative chips. So let me go ahead and we can go ahead and actually go straight to our answer. There's not a middle step that we have to do here. Since they're all negative, we just have to count them up. Negative 3 plus negative 2 is going to be negative 1, 2, 3, 4, 5. Our final answer, negative 3 plus a negative 2, is negative 5. Now I know what some of you are thinking. You're going, Miss Subin, I remember my 7th grade math teacher taught me that 2 negatives make a positive. You are remembering something, you're just not remembering this. 2 negatives make a positive when you are multiplying or dividing. When we're adding and subtracting, we have to decide if it's going to be positive or negative based on the values of the numbers. Since we're starting with a negative 3 and we're adding negative 2, we're going more negative. Negative 3 plus a negative 2 is going to be more negative because they're both going in the negative direction. Remember, when we're adding or subtracting, we have to decide on the sign being positive or negative based on the value of the numbers. The only time 2 negatives make a positive are when we are multiplying or when we are dividing. I know that's complicated, I know that's confusing, but we're going to be able to make it through. This problem is a little bit more difficult because we have a positive number and a negative number that we're dealing with. So there's going to be an extra step we're going to have to do. First thing I'm going to do is I'm going to go ahead and make sure my middle is an addition. It is. We're good to go. Then I'm going to represent each number using integer chips. First I have -6, -1, -2, -3, -4, -5, -6. Then I have a +6, when there's no sign it's positive, which I can represent with 1, 2, 3, 4, 5, 6. This kind of problem is going to be a little bit more difficult because we have positive and negative integer chips. We don't want to just count them up because some of them have a positive value and some of them have a negative value, so they're working against each other. We know that a positive and a negative make 0 when they balance each other out. So here I have, let me use my highlighter. Here I have a +1 and a -1. Well, +1 and -1, when those are put together, that makes 0. So what I can actually do is cross them out. And again, +1 and -1, those make 0. +1, -1 make 0. +1, -1, those make 0. I'm going to keep going. +1, -1, those make 0. You might be seeing where this is going. +1 and -1, those make 0. Wait a minute, I don't have any integers left. When I've crossed off all my integer chips, that means that the original numbers were opposites of one another. -6 and +6, those are opposites of each other. When we add opposites, that is our case where we're going to end up with an answer of 0. This is not positive, nor is it negative. This is exactly in the middle of our number line. Here's another problem we're going to be using what we just learned, but our answer is not going to be 0 this time. We got 0 last time because we added opposite values. -6 plus +6 made 0 because they were opposites. Here, we have 2 and -4. They're not opposites because they're not the same distance from 0. They're going in opposite directions because one of them is positive and one of them is negative. However, they will not equal 0 because they aren't the same distance from 0. They don't have the same absolute value. So let's go ahead, start with addition in the middle, and let's represent each of these numbers using our integer chips. So here I have +2 and -4. We can't write our final answer yet because we have some positive and some negative. We can only write our answer when we either have no chips left, which is 0, or we have only positive or only negative chips. So for this example, let's try to make some zeros like we did on the last one. We know the final answer won't be 0, but there are some chips here that will cancel each other out. I have a +1, and a -1 that when I combine them together, they make 0. I have a positive and a negative that when I put them together, they make 0. But now I'm out of those positive chips. So I can't make any more zeros. I can't cross off any more numbers. So instead, I'm going to count up what's left, and that's going to make my answer. All I have left are negative chips. So my answer is going to be negative. And my exact answer is the number of chips that we have. So we have 1, 2 negative chips. My answer is -2. One last example for us to try. All right, first thing I notice is that I like that we have an addition sign in the middle, so there's nothing tricky happening here. Let's go ahead and represent each of our numbers using our integer chips. I have 1, 2, 3, 4, 5, 6, 7, 8. Positive. Let's be combined with -3. As I'm looking at this, I notice that I have more positive chips than negative chips, so I'm going to make a prediction that my answer is going to be positive. I can't just count these up because I have positives and I have negatives, so the first thing I need to do is I need to make those zeros. +1, +1, and -1 make 0. So those chips, we don't need them anymore. +1 and -1, they make 0. So we don't need them anymore. +1 and -1, they make 0. We can't use them anymore. +1 and, wait, we don't have any more negative ones. So at this point, we can't cross off anything else. Since we only have positive integer chips left, what I'm going to do is I'm going to count up those positive integer chips, and that's going to be my answer as a positive answer. I have 1, 2, 3, 4, 5 positive integer chips left. My answer is +5. 8 plus a -3 makes +5.